Numerical problems on state space analysis of continuous systems. So obtain the state model of the system whose transfer function is given by y of s by u of s is equal to 24 by s cube plus 9s square plus 26s plus 24. So here y of s is output, u of s is input. So just write down the transfer function. Y of s by u of s is equal to 24 by s cube plus 9s square plus 26s plus 24. Now cross multiply the right hand and left hand terms. If you cross multiply, you will get y of s into s cube plus 9s square plus 26s plus 24. That is equal to 24 into u of s. Just expand the left hand side term. So just multiply y of s with this whole term which is in the bracket. You will get s cube y of s plus 9s square y of s plus 26s y of s plus 24 y of s equal to 24 u of s. Now take the inverse Laplace transform. If you take the inverse Laplace transform of the above equation, you will get d cube by dt cube of y of t plus 9 into d square by dt square of y of t plus 26 into d by dt of y of t plus 24 y of t is equal to 24 u of t. So by taking inverse Laplace transform, you will get this expression. Now instead of writing d cube by dt cube, you can write y triple dot t plus 9 into y double dot t plus 26 into y dot t, that is plus 24 y of t is equal to 24 u of t. So since this is third derivative, just put 3 dots on the y, and here since this is second derivative, put 2 dots on above y. This is first derivative, so put 1 dot above y. Okay. Now choose the state variables as derivatives. So x1 of t, let us consider x1 of t is y of t, x2 of t is y dot of t, x3 of t is y double dot of t. Okay, x1 of t is what? Is y of t, x2 of t is y dot of t, x3 of t is y double dot of t. Now this expression is our first expression. So this is equation 1, not first expression. This is equation 1. We have to replace these derivatives, y derivatives, with the state variables. So for that, let us see what we can do. Now we know x1 of t is what? Y of t. So what about x1 dot of t, that is first derivative of x1 of t, that will be y dot of t. Okay, and we know y dot of t is equal to x2 of t, that is in the previous slide. Y dot of t is what? X2 of t. Similarly, when x2 of t is equal to y dot of t, then x2 dot of t, that is first derivative of x2 of t, will be equal to second derivative of y of t, that is x2 dot of t is equal to y double dot t. Y double dot t is nothing but x3 of t. Y double dot is nothing but x3 of t. Okay, so if x3 of t is equal to y double dot t, that is x3 of t is equal to second derivative of y of t, then first derivative of x3 of t will be equal to third derivative of y of t. Okay, so these are our equations. Equation number 2, 3, 4, 5. Okay, these are our equations. Equation number 2, 3, 4, 5. Substitute them in equation 1. We substitute this in equation 1. So what is our equation 1 actually? It is y triple dot t plus 9 double dot t. Y triple dot t plus 9 y double dot t plus 26 y dot t plus 24 y of t is equal to 24 u of t. So y triple dot t, you can replace it with x3 dot t and plus 9 y double dot t, you can replace it with x3 of t. 26 y dot of t, you can replace y dot of t with x2 of t. Okay, plus 24 y of t. So 24 instead of y of t, write x1 of t, that is equal to 24 u of t. So in this equation, 24 y of t is equal to x1 of t, that is equal to 24 y of t. So 24 instead of y of t, write x1 of t, that is equal to 24 y of t. So 24 instead of y of t, write x1 of t, that is equal to 24 u of t. So in this equation, take write this equation in terms of x3 dot of t. So x3 dot of t, remaining terms you just send it to the right hand side of your expression, keeping x3 dot of t on left side. Remaining terms you just send it to the right side. If you send them to the right side, you will get x3 dot of t is equal to minus 24 x1 of t minus 26 x2 of t minus 9 x3 of t plus 24 u of t. Consider it as equation number 6. Okay. Now what is x1 of t? X1 dot of t is x2 of t. X2 dot of, I'm sorry. What is x1 dot of t? X1 dot of t is x2 of t. X2 dot of t is x3 of t. X3 dot of t is this expression. Okay. So x3 dot of 3 has all the variables x1 of t, x2 of t, x3 of 3. Whereas x1 dot of t has only x2 of t variable. Coefficient of x2 is 1. Okay. Coefficient of x2 is 1. Okay. What is the x2 dot of t is equal to x3 of t. What is the coefficient of x3 of t? That is 1. Okay. Now let us write down. Let us write down equation 3, 4 and 6 in matrix form. Okay, in matrix form if you write, you will get x1 dot x2, x2 dot x1 dot of t. If you want, you can write. I have not written here t. Sorry, my cursor won't listen to me. I have not written here t. If you people want, you can write t here. Where is my cursor? Yeah. So you can write t, x2 dot of t, and again x3 dot of t. You can write it. I have not written. So x1 dot of t, x2 dot of t, x3 dot of t is equal to what? So x1 dot of t is equal to only x2 of t, whose coefficient is only 1. So what about x1? x1 coefficient it is 0 and x3 coefficient is 0. 0, 1, 0. Okay, and next for x2 dot of t it was equal to only x3 of t. So what about x1 and x2 coefficient? 0. So 0, 0, 1. What about x3 dot of t? It is equal to what? Minus 24 x1 of t minus 26 x2 of t minus 9 x3 of t. So minus 24 x1 minus 26 x2 minus 9 x3. So minus 24 minus 26 minus 9. Now write down all this in brackets and the variables x1, x2, x3 in another square matrix. Okay. So this is one matrix multiplied with x1, x2, x3 plus. What about the input? What about the input? So input is equal to what? U of t. Okay. 24 u of t. So it is only 24 u of t. So 0, 0, 24 u of t. Okay. This is the given equation. So okay then. Okay then. Now what is our output? Y of t. Y of t is what? X1 of t. So y of t is equal to only x1 of t. What about x2 coefficient, x3 coefficient? They will be 0. So y of t is equal to 1, 0, 0. Okay, into x1, x2, x3 in another matrix. So it is in the matrix form. So y of t. Okay. This is it. This is our state equation. And this is our state equation. This is our output equation. Output equation and state equation. Okay. Now let us go to the next problem. State diagram of a system is shown. State diagram is given. Assign state variables and obtain state model of the system. So you have to obtain the state model of the system. State diagram is given here. So if you observe here, there are 4 integrators. You just observe in the given diagram. 1, 2, 3 and 4. 4 integrators are there. Okay. So since there are 4 integrators, there will be 4 state variables. Okay. So since there are 4, 1, 2, 3 and 4 integrators are there, there will be 4 state variables. Okay, so these state variables, they can be assigned at the output terminals of your integrator. So what is the input? This is input side, isn't it? These are the input sides. These are the input side of the integrator. So what is the output? This is the output. So you can write the state variables at the output side of your integrator. Okay, so we want the state model. So for that we need a state equation and output equation. So state equation can be formed by summing all the incoming signals of the signals to the input of the integrator, and we can equate it to the corresponding first derivative of the state variables. So let us see how to do that. Let us see how to do that. Okay, so first of all, as I said, assume state variables at the output terminals. Okay, so assume state variables at the output terminals. So the state variables are x1, x2, x3 and x4. These are the state variables. So if these are the at the output terminals, we have assumed the state variables x1, x2, x3 and x4. So now, so we already know if we have a derivative. So we already know if we have a derivative, we can, if we integrate the derivative, then we will get the variables. So if output is x1, then input will be the derivative of the x1 for the integrator. So input to the integrator is what? First derivative of x1. Similarly, input to the integrator whose output is x2 is derivative of x2, and output to the integrator whose output is x3, input to the integrator whose output is x3 is derivative of x3. Output to the integrator, input to the integrator whose output is x4. Okay, once again I will repeat. So this is an integrator. These are the state variables x1, x2, x3 and x4. So if x1, x2, x3, x4 are the state variables, then input to the integrator must be the derivative. So input to the integrator whose output is x1, whose output is x1, the input is x1 dot, and output to the integrator whose input to the integrator whose output is x2, input is x2 dot, derivative of x2, and input to the integrator whose output is x3 is derivative of x3, and input to the integrator whose output is x4 is x4 dot, that is derivative of x4. Okay, now let us determine these derivative values, that is x1 dot, x2 dot, x3 dot, and x4 dot. Okay, so I have considered the summing point, okay, summing point which is connecting to this integrator. So I want to determine x1 dot, that's derivative of x1, therefore that is my output. So what are the input signals to that x1 dot? Input signals are 3 u1 of t and 4 x4 from this diagram. Okay, 3 u1 of t, and this signal is coming from here, 4. Okay. Okay, so I want to determine x1 dot. So what are the input signals here at the summing point? These two are the input point, 3 u1 of t, and here there is 4. So what is x1 dot? That is 3 u1 of t plus 4 x4. Yeah, here you can see 4. So here x4 is signal is going through the 4. Okay, so we can't consider y2 of t here, it is output. Okay, so x4 into 4. Okay, so this is our x1 dot. Similarly, I want x2 dot. So consider the input signals that are coming to x2 dot. So input signals that are coming to x2 dot are these two summing points. So this input to this summing point is x1, u1, and 2u2, and it is connected to this summing point whose input is 3x2, and as well as this summation will go to this summing point, you will get x2 dot. So what is x2 dot? That is x1 plus u1 plus 2u2 minus 3x2. So here minus is there, therefore that's why minus 3x2. Okay, so simply I have rearranged the terms. X2 dot is equal to x1 minus 3x2 plus u1 plus 2u2. Okay, similarly now I want to determine x3 dot. So x3 dot is equal to, this is the summing point, here input to it is x2 and 3u2. Okay, so minus x, here minus is there, therefore minus x2 plus 3u2 of t. Okay, I have not written t here, it's okay. If you want you can write here u2 of t. Okay, similarly x4 dot. So x4 dot, that is first derivative of x4, is equal to the whatever summing point that is connected here. I am taking all these terms from this x4 dot, you can see here. So 4 into x4 plus there is x3, okay, plus x3. Okay, so where is it? Yeah, so x4 dot is equal to x3 minus 4x4. Here minus is there, that's why minus. So x3 minus 4x4 is x4 dot. Okay, so you can write all these equations together. Okay, you will get the state equations. Okay, so now we have got the state equations. Now you can write them in matrix form. Okay, you can write them in matrix form. So right hand terms and left hand terms, all those terms can be written in matrix form. So this is the matrix form. So x1 dot, x2 dot, x3 dot, x4 dot matrix. And just see in this equation only x4 is there. This is our input term. Only x4 is. So x1, x2, x3 are 0 here. So x1, x2, x1, x2, x3 coefficients are 0. Only x4 term is there. What is the coefficient of x4? Minus 4. So minus 4. Okay, next x2 dash or x2 dot, sorry. x2 dot, x1 is there, x2 is there. That's it. So x1 and x2 is there. Okay, x1, x2. What are the coefficients of x1 and x2? x1, x2 coefficients are 1 and minus 3. x3, x4 are not there. So 0, 0. Similarly for x3 dot, only x2 term is there whose coefficient is minus 1. Only x2 is there whose coefficient is minus 1. So 0, minus 1, 0, 0. Similarly for x4 dot, x1 and x2 are not there. Only x3 coefficient 1, x4 coefficient minus 4 is there. So 1, minus 4, 0, 0, 1, minus 4. So this is it. Write down in a matrix, and besides to it, write down x1, x2, x3, x4 in another matrix plus what are the coefficients of inputs here? So if you see here, so u1 is there and the coefficient of u1 is 3. Okay, so u2 is not there in the above first equation. So 3, 0. Okay, in second equation u1, u2 both are there. So coefficient of u1 is 1, coefficient of u2 is 2. So 1, 2, u1, u2. So what about the third equation? In the third equation, only u2 is there, u1 is not. Coefficient of u2 is 3. So therefore 0, 3. Okay. Similarly in fourth equation, u terms are not there. In this equation, u terms are not there. Since u is not there, therefore u terms are not there. Therefore 0, 0. Coefficients of u are 0, 0. 0, 0. You just put it in a matrix and write down u1, u2 in another matrix. Why? Because here, if you observe, there are u1 and u2 are the input terms. Okay, y of t and y2 of t. This is y of t means y1 of t. This must be y1 of t. If this is y2 of t, then this above equation must be y1 of t. Okay, y1 of t, y2 of t. So this is it. These are the state equations. Now let us see the output equations. Okay. So let us see the output equations. Let us go to our circuit. So if you observe here, not here, here. If you observe here, y1 of t is equal to x2. y2 of t, I will erase all inks. So this is y1. y1 is missing. Okay, so y1 of t is equal to what? x2. y2 of t is equal to what? x4. Okay, y1 of t is equal to x2 and y2 of t is equal to x4. Therefore, output equation y1 of t, that is y1 of t, I have not written t here. So y1 of t is x2 and y2 of t is x4. So you just put it in a matrix form. So y1 of t, y2 of t. Here our variables are x1, x2, x3, x4. So y1 is equal to only x2, means coefficient of x2 is 1. So 0, x1 is not there, x3 and x4 are not there. So 0, 1, 0, 0. And y2 is equal to only x4. Therefore, coefficient of x1, x2, x3 are 0. 0, 0, 0, 1. So this is our output equation. So state equation and output equation. Okay, together they are known as state model of the system. Okay, together they are known as state equation, output equation. Together they are known as state model of the system. Now let us solve one more numerical problem. Construct a state model. Construct a state model for a system categorized by differential equation d cube by dt cube y plus 6 into d square y by dt square plus 11 dy by dt plus 6y plus u equal to 0. Okay. And also give the block diagram representation of the state model. So we have to construct the state model as well as we have to design the block diagram. Okay. So let us see how to do that. Okay. So here, this is our given equation. This is our given equation. So here, let us choose y and its derivatives as state variables. Okay. As state variables. So here we can see third order differential equation. So since the highest order of the differential equation is 3, therefore there will be 3. Let us assume there are 3 state variables. Okay. So let us assume our state variables are x1, x2 and x3. So what is x1 of t or x1 equal to y? Let us assume x1 equal to y. So if x1 equal to y, then x1 dot, that is first derivative of x1 will be equal to first derivative of y. Okay, x1 dot equal to y dot, I can say, that is equal to x2. Similarly, x2 dot equal to d square by dt square of y, that is equal to what? D by dt of x2, that is equal to x3. Similarly, x3 dot is equal to d cube by dt cube of y. So consider all these equations as 2 and substitute this equation 2 in 1. If you substitute all this in equation 1, you will get x dot 3 plus 6x3 plus 11x2 plus 6x1 plus u is equal to 0. So in this, determine x dot 3. So x dot 3 is equal to minus 6x1 minus 11x2 minus 6x3 minus u. So here state equations are x1 dot is equal to x2 and x2 dot equal to x3. x3 dot in the above, from the above equation we have got minus 6x1 minus 11x2 minus 6x3 minus u. So with all these equations you can represent them in matrix form. You will get the state equation. So just write it down in matrix form. So just write it down in matrix form. x1 dot, x2 dot, x3 dot is equal to this equation. x1 dot is equal to x2. So x1, coefficient of x1 and coefficient of x3 is 0. 0, 1, 0. Similarly, x2 dot is equal to what? x2 dot equal to x3. Therefore, coefficient of x1 and x2 are 0, 0, 0, 1. What about the x3? Coefficient of, there is coefficient of x1 is minus 6, x2 is minus 11, x3 is minus 6. So minus 6, minus 11, minus 6. Okay. So put all these terms in a matrix and write down another matrix x1, x2, x3 plus what about the input? Okay. So for x1 dot no input, x2 dot no input, for x3 dot minus u, means coefficient of u is minus 1. So 0, 0, minus 1 u. Okay. And what about the output equation? Y is equal to what? X1. Here we have here we have assumed in equation 2 y is equal to x1. So if y is equal to x1, then y is equal to what? Coefficient of x1 is 1. 1, 0, 0. x2, x3 is not there. So y equal to 1, 0, 0. That is x1 by x2. I'm sorry. So y equal to within bracket, within the matrix 1, 0, 0 into within matrix x1, x2, x3. So this is our output equation. This is our state equation. Okay. Now we have to design the block diagram. So for that, okay, in order to design the block diagram, there is a very simple, you just take the equations, state equations. Okay, just take the state equations and let us design the block diagram. For that, we just observe, if you observe the state equations, we observe the stating x3 dot has all the state variables x1, x2, x3. It has all the state variables. Therefore, let us start with x3 dot. Okay, consider x3 dot. So x3 dot is equal to what? It is equal to minus 6x1. Okay, minus 6x1, that is this, isn't it? Minus 6x1 minus 11x2 minus 6x3 minus u. U means what? Input. So u is input, therefore consider u and multiply it with minus 1. You just take an transfer function, okay, block, write down minus 1 as its open loop transfer function, okay, and write. Now you will get the output of this is minus u. So this is minus u. So minus u, okay, minus u plus what? Minus 6x1, I will take the laser. Minus 6x1 minus 11x2 minus 6x3 is equal to x3 dot. Okay, so here this is 6x1. So if this is 6x1, then here I can consider x1 as input and I can multiply x1 with the transfer function, and assuming 6 as the transfer function. So write 6 and consider here x1. Okay, consider here x1. Okay, now this is 11x2. Consider 11 as the transfer function, right? x2 as the input. Here also consider 6 as the transfer function. Consider x3 as the input. x3 as the input. Okay, consider x3 as the input. Okay, so what is here? x3 dot is there. So if this is x3, okay, so what should be in between x3 dot and x3? Integral should be there. So all these things we have to assume. We have no other way. We have to think and plan. So just send the signal to the numerator, not numerator, to the above side, and just see here x3 dot is there. So put an integral, write x3, from there x3 into 6, you will get 6x3. If you add it with something else, your x3 dot equation you will get. Okay, and we already know x3 is equal to x2 dot. x3 is equal to what? x2 dot. So since x3 is equal to x2 dot, integral of x2 dot is what? x2. So now just join this line here. Okay. Okay, similarly x2 is equal to what? x1 dot. So integral of x1 dot is x1, and x1 is equal to what? Y. Okay, so you can write y here. I'm unable to write with my mouse. So input is u, output is y. Okay, so you just join this line with this line with this, and this line with this. Okay, so it's actually it's easy. It may look complicated, but construction of block diagram is easy. So if you are able to follow the lecture, just click on the hand symbol, just like this video, so that it can reach to many people. Thank you.